Hello everyone, this is Mr. Fawcett back for part 2 of our angle pairs lesson. This lesson we're going to go through 3 practice problems dealing with using those angle pair relationships to set up and solve different types of equations. So let's go down to, you know what, we're actually going to do 6 problems. I just forgot that these first 3 were rather short. So we're going to look at number 9 first. It does tell us that we can assume R, P, and U are collinear, so we just know that this line right here, or what appears to be a line, this is actually a line because it's saying R, P, and U are collinear, so they all lie on the same line. And we also know that Q, P, and T are also collinear, so this is an actual line right here. That's just a way for them to say that if it looks like a line, and it is a line here. So we need to find one angle that is supplementary to angle QPU. So let's trace out QPU. QPU. We want to find an angle that's supplementary. Well, QPU is part of a line, right? If we trace this other angle that forms a linear pair, well, then we have the other part of that larger angle that forms a line. So if it forms a line, it's going to be 180 degrees altogether, which makes them supplementary. So angle QPR is one possible option. There is another option. It would be if we didn't want to use this one right here, we could also use this angle, because then we also have a linear pair, and they'll equal 180. So we could say, or angle TPU. Number 10 says name a pair of vertical angles. So again, we want to look for that x. So is there a set of angles here formed by two intersecting lines that forms an x? And we do have these angles. One is here with RPQ rather, and the other one is TPU. You could also say QPR or UPT. So we have angle RPQ and angle TPU. You'll notice that these are the same angles from our answer to number 10. Or sorry, number 9. Now, let's just be careful here. Let's talk about some other angles maybe, or you might have chosen. Maybe you chose these angles right here, QPU and SPT. So these angles do share a vertex, and they look like they're opposite one another, but you have to go back to that part of the definition that says they're formed from two lines. So they should be formed by an x, right? And it's no problem for this part, right? Here's a line that forms parts of those angles. But we run into a problem here because we'd have to keep going and pull this red segment over, or that red ray over to that green line for these to be true vertical angles. So just make sure that the vertical angles you're choosing are formed by two intersecting lines. And you can also kind of tell here that these angles don't quite look congruent, which is another characteristic of vertical angles. So the red and blue will be the same angle measurement. So if they don't look the same, they're not going to be vertical angles. And you can't fake vertical angles on a paper either. So you can't draw them so they are vertical, but they don't look vertical. So if they don't look vertical, they're not going to be vertical. Okay, number 11. We need an angle that's complementary to angle SPR. So let's quickly look at angle SPR. SPR, I need one that's complementary. So this one actually I think is possibly the toughest question here. here's where we have to go with this. Complementary means 90 degrees. Well, we have this angle that's 90, okay, denoted by that little red box. And we know it's a part of this entire line, TPQ. So if this angle right here is 90, then this entire angle right here should be equal to 90, right? Because they have to form 180 degrees because they form a straight line. They would be a linear pair. If green is a part of the other 90-degree angle, well, then we just need to know what this angle is, because then the blue and the green, we can say that those must equal 90 degrees together. And our blue angle is angle RPQ again. All right, let's move on to question 14. I'm not going to do all of these because some are similar, some I think are a little bit easier, but I think 14 is a good one to work through. So we have, and again, no diagram here, so we've got to set up our own diagram or understand whatever relationship's going on. So it says angle ABC and angle FGK are supplementary. And it gives you the measurements of these angles. And actually, maybe I'll just put this on the same line so it's easier for you to see. There we go. So the measurement of angle ABC is equal to this expression right here, 4x plus 7. And the measurement of FGK is equal to 6x minus 17. So you could draw a diagram if you wanted to and label those angles. It actually isn't necessary as long as we understand what supplementary means, right? So supplementary means that the two angles should add together or sum to 180 degrees. Well, if we know what the red angle is, that's 4x plus 7. We know what the blue angle is, right? That's 6x minus 17. Well, we know that they have to be equal to 180 degrees because they're supplementary. So we can just go ahead and solve for x. I'm going to combine my like terms, my 4x and my 6x, to get 10x. The 7 and the negative 17 combine to get negative 10. Then I'm going to add 10 to both sides. I'm going to divide both sides by 10, and I get x is equal to 19. Now you may be tempted to move on because we found what x is equal to, but it says solve for x and then find each angle measure. So we have to go back, find a measurement of angle ABC, measurement of angle ABC. That is going to be equal to, oops, let's just get rid of this bar, no need for that. So measurement of angle ABC is equal to 4x plus 7. We know that x is equal to 19, so 4 times 19 plus 7. 4 times 19 is 76, plus 7 is 83. Again, you can take your time to do this math. But this would be one angle measurement. Two ways you could find the blue one, FGK. You could just subtract 83 from 180, or you could go through and find it. I'm going to go through and find it just because that'll make me more sure of the work that I did. Make sure that's correct. So that's equal to 6x minus 17. So we have 6 times 19 minus 17. Let's make that an actual 9. That's a little better. 6 times 19 is 114. Minus 17 gives us 97. And if we add these two together, those do add up to 180. So we are good. Okay, that's it for this problem. Let's move on. And we're going to look at the application problem down here, and we'll finish with this one. So let's read through it. It says, given the diagram below, light passing through a fiber optic cable reflects off the walls in such a way that angle 1 is congruent to angle 2, angle 1 and angle 3 are complementary, angle 2 and angle 4 are complementary, And then it says if the measurement of angle 1 is equal to 38, find the measurement of angle 2, the measurement of angle 3, and the measurement of angle 4. So it sounds like a lot of information. You know, they use the words fiber optic cable, which sounds intense. But if we break this down, it's actually a very simple problem at the root of it. What I would do is I would, again, label anything that's not labeled. So it tells us where angles 1, 2, 3, and 4 are, but it doesn't have the 38 degrees labeled. So let's start there. Angle 1 is equal to 38 degrees. Now, it tells us that angle 1 is congruent to angle 2. Well, if two angles are congruent, then they have the same measurement. So angle 2 also must be equal to 38 degrees. And I would also just write this down on your paper. So measurement of angle 2 equals 38 degrees. And it's important that you understand why, right? When we start to write our proofs, you'll have to write a little justification down that lets me know, why it's 38 degrees. So you would have to write something down like it's congruent to angle 1. Which means they have the same measurement. Now it says angle 1 and angle 3 are complementary. Well, what does complementary mean, right? Complementary means that two angles need to sum to 90. So we could actually just write a little equation here. We could say the measurement of angle 1 plus the measurement of angle 3 is equal to 90. We know what the measurement of angle 1 is. We know that that's 38. So if we subtract 38 from 90, and we are subtracting it from both sides, but on the left side it's going to simplify, we are left with 52. So the measurement of angle 3 is 52 degrees. Your reasoning for this equation, right? Angle 1 and angle 3 are complementary. I'm going to abbreviate because I'm running out of space. Same idea for angle 2 and angle 4. So I can come up with another equation, right? I can say, because those are both complementary as well. So measurement of angle 2 plus the measurement of angle 4 equals 180. I know that the measurement of angle 2 is 38. So I'm going to, that's a mistake. 90, because they're both complementary. I guess I better fix this down here as well. So 38 plus the measurement of angle 4 is equal to 90. And I'm doing the same subtraction as I did to find the measurement of angle 3. 90 minus 38 is 52. And we are talking about degrees. So our justification for this equation would be the same thing. Angle 2 and angle 4 are complementary. So while it didn't say we had to justify anything we wrote down here, I'm trying to get you to practice doing that, because it's going to come in handy when we then transition to full-blown proofs. You're not going to be like, oh, I don't know how to justify. I've never done that before. So at least think through the justification, be able to say it either out loud or in your head for why you're writing down an equation. But look, feel free to write it on your paper too. Right now it's not required, but I certainly could say on a test, explain why this equation is true. How did you come up with it? So you'll always want to be prepared to step in and say, I can not only do this, I can explain why I did it. Okay, I look forward to seeing you next time. Until then, as always, enjoy your day. This has been Mr. Fawcett with another geometry lesson.